Assalamualaikum to Dr. Amzari. My name is Noor Eliza and my matrix number is 202751. Today I'm going to present about our assignment 1, which is differential equation in academic disciplines. So for the summary, this report is regarding the principle and application of differential equation from various types of fields. Differential equation is the equation which introduce derivatives. Those which introduce integrals are called integral equations, and those which introduce both are called integral differential equations. There are two main categories, which is ordinary differential equation and partial differential equation. Assalamualaikum to Dr. Amzari. My name is Noor Eliza and my matrix number is 202751. Today I'm going to present about our assignment 1, which is differential equation in academic disciplines. So for the summary, this report is regarding the principle and application of differential equation from various types of fields. Differential equation is the equation which introduce derivatives. Those which introduce integrals are called integral equations, and those which introduce both are called integral differential equations. There are two main categories, which is ordinary differential equation and partial differential equation. The objectives is to be able to identify the types of a given differential equation and select and apply the appropriate analytical technique to find the solution of first order and selected higher order ordinary differential equations. Next is to be able to apply the use of differential equation in various types of fields.
Hello and Assalamualaikum. My name is Nur Faiza binti Kamaruddin and my matrix number is 203736. Today I will present about the introduction to differential equations. So, differential equations origin was started by the English scientist and mathematician, which is Sir Isaac Newton, and the German philosopher and the mathematician Gottfried Wilhelm Leibniz in developing the new science of calculus in the 17th century. Newton classified the first order of differential equations in this form, which is dy over dx equal to fx, dy over dx equals to fy, or dy over dx equals to fxy. He also developed infinite series method for solving. Dy over dx equals to fxy when fxy is a polynomial in x and y. So, differential equations are not all about physics only. This equation can be used to model and understand the situation in biology, economics, chemistry, geology, and many more. These equations play such a big role in science work. Before explaining the definition of differential equation, let's just talk about what a differential can be used. So, differential equation can be used in orbit of spaceship, the amount of money in a saving account, the description of a radio wave, and the amount of current and voltage in electric circuit, and on and on. These all can be described by using differential equations. Okay, so there are two types of differential equation, which is ordinary differential equations and partial differential equations. Ordinary differential equation is an equation that involves an unknown function of a single variable, its independent variable, and one or more of its derivative. While partial differential equations involve two or more independent variable and unknown function, and partial derivative of the unknown function with respect to the independent variable. And in fact, that partial differential equations is a little bit more harder, which is more difficult to solve than ordinary differential equation.
The theory of differential equations has become an essential tool of economic analysis, particularly since computer has commonly available. A differential equation expresses the rate of change of the current state as a function of the current. A simple illustration of this type of dependence is changes of the gross domestic product (GDP) over time. Consider state X of the GDP of the economy. The rate of change of the GDP is proportional to the current GDP, as shown as this equation, where T stands for time and IT the derivative of the action X with respect to T. The growth rate of GDP is X. If the growth rate G is given any time P, the GDP at T given by solving the differential equation. The solution is as shown as at here. This solution tells us that the GDP decays increases exponentially in time when G is negative, so we can explicitly solve the above differential function when G is a constant. So it is reasonable to consider that the growth rate is affected by many factors, such as current state of economic system, accumulated knowledge of economy, international environment, and many other conditions. This means that the growth rate may take on a complicated from gxt. The economic growth is described as this equation here. So in generally, it is not easy to explicitly solve the above function. There are various established methods of solving different types of differential equations. The variable t often stands for time, and solution we are looking for, xt, usually stands for some economic quantity that changes with time. Therefore, we consider xt as a dependent variable. For instance, it equal to t to xt is an ordinary differential equation. Ordinary differential equations are classified as autonomous and non-autonomous. So the equation as shown here with a and b as parameters is an autonomous differential equation because the time variable t does not explicitly appear. If the equation specially involves t, we call equation non-autonomous or time-dependent. For instance, this equation here is a non-autonomous differential equation. The equation it equal to ax t plus b with a and b as parameters is first order autonomous differential equation. The equation shows here is a second order equation where the second derivative it is the derivative of xt.
So now I'm going to explain about the application of differential equation in chemistry. Differential equations play a central role in the mathematical treatment of chemical kinetics. Differential equations is used to calculate the rate of reaction. So from this, we can say that the constant K is the rate constant of reaction and is measure of how fast or slow the reaction is. It depends on the reaction itself, which is the chemical compounds A and B, and the example is such as temperature. So the unit K also depends on the particular mechanism of the reaction. The rate of reaction will be defined as the number of moles A that disappear or the number of mole B that appear per unit of time and volume. However, because of the rate is a positive quantity, we will use a negative sign if we look at the disappearance of A and the rate of reaction is proportional to the concentration of A. So this is the equation. So this is one of the example on how to calculate the rate of reaction by using the differential equation.
Assalamualaikum and hi to Dr. Amzari. My name is Muhammad Azim bin Zulkifli. My metric number is 203244. So today I'll be talking about the application of differential equation in geology. In geology, differential equation is used to measure gravity. Although right now we live in this modern world where there are so many futuristic devices that we can use to measure gravity, it is important for us to know how to calculate the gravity by using theoretical method. In geophysics, torsion balance is used to calculate gravity. The torsion balance measures the distortion of the gravitational field. In 1988, Ferguson states that by measuring the rotation of a torsion balance beam, the gravitational force will act on two masses at the end of the beam so that we can calculate the gravity. Newton says that force which produce the torque in the beam are the first derivative of gravity. Their rates of change must be the second derivative of potential. So right now I will show you the formula of torque. M in the formula is the mass of weights on the beam, where h is the vertical distance between the weights, 2L is the horizontal distance between the weights, the alpha is the angle between the beam and the x-axis, and there are four second derivatives of the gravitational potential. So, since the torque will produce a rotation of the balance, so this is the formula, where the n is the deflected position, n naught is the undistributed position. P and Q are constants and they are depend on the physical parameters of the instruments. So, in calculating gravity, we will get four unknowns in the equation, which they are the four second derivative, and there is also no way of us measuring the n naught because it is also unknown. So in this application, it is not necessarily to solve the differential, because in practice we will calculate in 5 different directions so that we can solve the application by using the simultaneous linear equation in 5 unknowns. By doing that, we can calculate the gravity.
Assalamualaikum and hi doctor. Today I'm going to present about the application at assignment 1, which is the application of differential equation. So before I start, let me introduce myself. My name is Muhammad Fazil Nur bin Abakar. My matrix number is 203715 and I'm from group 4. So my part is I'm going to explain about the application of differential equation in biology. So differential equation is a fundamental in modern science. It is used extensively in biology, such as biochemical reactions, population dynamics, organism growth, and spread diseases. And it is the vast majority of quantitative models in cell and molecular biology are formulated in terms of ordinary differential equation for the time evolution of concentration of molecular species. So differential equation also used to calculate the concentration of drugs in living organism and to calculate the half-life of radioactive. So next is here's the example of differential equation. Here's the example of a graph which is applying the differential equation to calculate the growth and decay. So next is here's the one of the example of the calculation of bacteria that applying the differential equation. So the question is, in a culture, bacteria increase at a rate proportional to the number of the bacteria present. If there are 400 bacteria initially and are doubled in 3 hours, find the number of bacteria present in 7 hours later. So the solution is, let x be the number of the bacteria and the rate is dx over dt. So since the number of bacteria is proportional to the rate, so we can we can simplify the equation into dx over dx equal to k dt, because first the dx over dt and equal to kx. So if we simplify the equation, it will become like this, the first equation. So since there are 400 bacteria initially and they are double in 3 hours, we can integrate the left side equation from 400 to 800 and integrate the right side from 0 to 3. So if you can see the equation right here, integration of 400 to 800 dx over dx equal to k integration of 0 to 3 dt. If we solve the equation, we can get the k equal to 1 over 3 ln 2. Substitute the value of k into the second equation, which is into the first equation, and it will become like dx over dx equal to ln 1 over 3 ln 2 dt. So we can easily find the number of bacteria present after 7 hours by substituting the value of integration of 400 to x, which is the value that we want to find. Dx over dx equal to 1 over 3 ln 2 from integration from 0 to 7 dt. So if we solve the equation, we can get the value of x, which is 2016. So after 7 hours, there was 2016 value of bacteria present. So that's all for me, doctor. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Okay, today I will present and explain to all of you about my group assignment 1. Okay, I will list out and explain briefly about my contribution and my part for this group assignment 1. Okay, before we go further, I will introduce myself. I'm Shukri Afifi bin Muhammad Arifin. My matrix number is 202794. The topic for this group assignment 1 is differential equation in academic disciplines. My contribution is application of differential equation in physics fields or example in physics, and also conclusion. Application of differential equation in physics. I choose the free falling ball for the applications. A ball is thrown vertically upward with a velocity of 100 milli per second, ignoring a resistance. Okay, first equation that we get is dv over dt equal to negative g. So we're separating the variables because we want to integrate both sides. So we move the dt at the right side. Okay, the first question, the velocity of the ball at any time. Like I said before, we will integrate both sides. So we will get at the left side v minus 100 and negative g t. So we remove negative gt at the right side. So v equal to 100 negative gt. So we get the equation for the first question, v equal to 100 minus 9.8 t. The second question is the distance traveled at any time. Okay, we know velocity is the time rate of the distance. V equal to dh over dt, like v equal to ds over dt, but this situation we use v equal to dh over dt. So dh over dt equal to the equation before, v equal to 100 negative 980. So we move dt at the right side. So we will integrate it, and we will get h equal to 100t minus 4.9t squared. So this is the answer for question B. See the maximum height. At the maximum height, the velocity is 0. So we put 0 at the V. So we will get t equal to 10.2 seconds. So we input the t 10.2 seconds to the equation before. So we get h equal to 510.2 meter. For this example, it is used ordinary differential equation to solve the physics problem. Okay, so the next part, conclusion. Differential equations can be applied throughout a variety of areas. It is also play major role in applications of engineering, physics, chemistry, and many more. With the help of this differential equation, the students are able to communicate mathematical ideas with their surroundings and for the future. They can apply their knowledge and understanding to mathematics in daily life, particularly to applications such as economics, geology, arts, and so on. So at this situation, we know that differential equation is very important to all of human in this generation because all of many areas and field use this concept of differential equation. That's all from me. Thank you.